I'm Professor Rad, and this is Precalc video 322, inverse trig on a calculator. So our calculators have inverse trig functions for sine, cosine, and tangent, but they don't have inverse trig functions written on them for inverse cosecant, secant, or cotangent. So we're going to develop a property to help us use our calculator to make that approximation, and then we'll go ahead and practice that doing a few examples. So suppose I wanted to find inverse cosecant. So we're going to call this a note. So let's say I have inverse cosecant of a value, and that's going to equal some angle. So remember that inverse trig functions take a ratio as the input. So they take like a real number as an input, and they're going to spit out an angle. They're the opposite of trig functions. So I'm going to rewrite this equation in terms of sine. So the way that I'll do that is first by rewriting this in terms of cosecant instead of cosecant inverse. So this equation means that x is equal to cosecant of theta. So remember when we were finding our inverse trig functions, we could think of it as like, in this case, taking cosecant of both sides. So cosecant and cosecant inverse would cancel, and that'll give us just the x. And this is equal to cosecant of theta. Now, cosecant of theta is the reciprocal of sine. So I can rewrite this as x is equal to 1 over sine of theta. And basically what we're going to do is we're going to rewrite this equation so that we have sine of theta equals something. So I can multiply both sides by sine of theta, and that will give me x times sine of theta. That's going to equal 1. And then I can divide both sides by x in order to get sine of theta on its own. So now we have that sine of theta is equal to x. What I would like to do, since we started out with an inverse trig equation and set that equal to theta, I want to do that same thing here at the end. So I want to write this in terms of just theta, and so theta equals instead of 1 over x equals. So to do that, I can take arcsine of both sides or the inverse sine of both sides. That will cancel on the left, and I'll get just theta. And on the right, we'll get inverse sine of 1 over x. So what we've developed here is a shortcut or an alternate way of finding inverse cosecant. So to find inverse cosecant, you're not going to take the reciprocal of inverse sine. You're going to take the reciprocal of the ratio and then inverse sine that. And this is the case for all of our reciprocal relationships. So kind of our key takeaway here is if you have inverse cosecant, that's going to equal inverse sine of the reciprocal of the argument. If you're looking for inverse secant, that's going to be inverse cosine of the reciprocal of the argument. And then similarly with inverse cotangent, that's going to be the inverse tangent of the reciprocal of the argument. This also makes sense because if we think about inverse functions, they're undoing the function. So if I have if I have inverse cosecant of a thing, I want to undo that relationship to go into sine first. So I'm going to take the reciprocal first, and then I'm going to undo the sine. So that's why we're having the reciprocal of the argument, not the reciprocal of the function like we do with regular trig. Okay, so now that we have that, let's go ahead and use our calculators to find a few different values. For this example, we're going to find 4 values on our calculator. We're going to find the inverse sine of a third, the inverse cosine of -4/9, inverse cotangent of 1/3, and inverse cosecant of -5. Now, when I go to find these, I am going to make sure that my calculator is in radian mode. So my graphing calculator has decided it doesn't want to work today. So we're going to go with the TI-30X2S. But on your graphing calculator, you just want to make sure you're checking with the mode button to make sure you're in radian mode. And on this calculator, if you're using the TI-30X2S, we're going to use the degree button over here. And we just want to make sure rad is underlined. So we're in radian degree or radian mode. Once we have that, to find inverse sine of 1/3, inverse sine is going to be one of the buttons on the calculator. So on the TI-30X2S, we can see that right above the sine button, we have sine -1. So that's your inverse sine key. We'll get there by hitting second sine. And there we have our sine inverse. And now we're going to type in 1/3. So the same is true on your graphing calculator. Usually the inverse sine button is going to be found by hitting second sine. And when I hit equals, I got a nice, beautiful decimal. Remember, these are radian measurements, so very often pi is a factor in that, and they're in terms of fractions, so you might have a denominator like 13 or 7, where the decimal is really crazy, so you're often going to get really wacky decimals for these values. So that's why we're going to be rounding to the nearest thousandth. So on this one, I have 0.3398. So to the nearest thousandth is going to be 0.340. We can go ahead and find inverse cosine the same way. So this one, I'm just going to hit second cosine and type in -4/9. And this time I got a 2.031. And just a reminder that the squiggly equals means approximately equal to, because we're rounding our values here. So these are not exact values, they're rounded to the nearest thousandth. For the last two, that's where these properties are going to come into play, because we have cotangent and cosecant, and this calculator is only going to do sine, cosine, and tangent, and their inverses. So to find inverse cotangent, I'm going to need to take the reciprocal of the argument, and then I can write it in terms of inverse tangent. So this is going to be the inverse tangent of 3/1, which is just 3. Now I can go ahead and use my calculator. So inverse tangent of 3. And to the nearest thousandth, this will give me 1.249. And for inverse cosecant, I'm going to write that as the inverse sine of the reciprocal. So this is inverse sine. And the reciprocal of -5 is -1/5. So I'm going to find inverse sine of -1/5. And to the nearest thousandth, this is -0.201. All right, so that's going to be it for this video of using your calculator to find the inverse trig expressions. Yeah, so that's it, nice and short. I hope you found this video helpful, and especially the development of this identity. And in our next video, we're going to start to solve some equations that involve trig functions. So looking forward to working with you on that. In the meantime, I hope you have a magnificent day, and I'll see you next time. Bye for now.